So when you're solving the differential equation that has got something like of the form d, e, h, and I, where the variables like x and y are like together. Here you can see that x and y are together. Here you can see that x and y are together. So if your derivative is of the implicit form, where the derivative is actually like a function of x and y, so the first strategy is that you isolate the variables to solve the differential equation. So now let's take the first example, which is d here. Now in d, what we got is the derivative expression is 2x times root y. Now first step is to bring, so let's say if I've got dy by dx is 2x times root y. I'm just going to isolate y one side. So I'm just going to bring this down here and this down up here. So dy over root y equals to dx 2x times dx. So once I get this step, after this, I'm going to integrate both the sides. So now I got dy and dx, either of them, either side of the equals to sign. So what you do is when you integrate this first one, so integration of dy over root y can be written as y to the power negative half times dy. So it is y to the power half over half plus c, you can say. Now, while you're doing the integration both the sides, you can attach the constant on either of the side of the equals to sign. You don't need to attach like plus c here and plus c here, because if I take this as c1 and this is c2, eventually if I bring c2 minus c1, that's going to be another constant. So now after this, what you do is you got to simplify this. So if you make y the subject of the formula, you're going to get this. So I took c here as a integration constant. So here, if I multiply half here, so you get half x squared plus c over 2, and you get rid of this root here from one side, so you get the square term. And you can take c by 2 as another constant. So these problems where they don't give the initial condition, so like some of the cases they'll give you x and y, where you can substitute x and y values to get the exact constant value. So let's take the another example. Now consider, let's say, y sine x. So when you're differentiating, let's say y sine x, so dy over dx is y sine x. So what you're going to do is you're going to first bring x one side and y other side. So dy over sine x equals to dy over y. Actually, don't bring sine x down. So dy over y equals to dx times sine x as it is. So if I integrate both the sides, so dy over y is actually ln of absolute value of y, because you don't know what y values it can take. So that's why you got to put absolute value, equals to sine x integration is negative cos x plus c. So when you do that, you get this step. Now you got to get rid of the, let's say if you want to make y the subject. So absolute value of y will be, let's say, a negative cos plus c. So if you remove ln, so it'll be y equals to e to the power, absolute value of y is e to the power negative cos x plus c. And what we get is y. If I remove this absolute value, you get plus minus e to the power negative cos x plus c. So if you further want to simplify, you can break this power down and you get y is plus minus e to the power negative cos x into e to the power c. So this part that you saw here is another constant. Plus minus e to the power c is another constant. So I can take that as a and e to the power negative cos x. So this is the general solution of this equation. Now let's take the third one, which is dy over dx is 3x squared e to the power y. So in third case, what we do is you once again isolate. So dy over e to the power y is, let's say, 3x squared times dx. Now integrate both the sides. So you'll get e to the power negative y dy equals to integration 3x squared dx. Now if you integrate this, you get e to the power negative y over negative 1 equals to 3x cubed over 3 plus c. So 3 is gone. So you get e to the power negative y equals to negative x cubed negative c. So you get negative y equals to ln of negative x cubed negative c. And of course, you bring minus this side. So you get the answer. So that's this part. Here now the fourth one is dy over dx is y plus 2 over x minus 1. So you, let's say when you integrate this one, so dy over y plus 2 equals to dx over x minus 1. And if you integrate both the sides, you get integration of 1 over y is ln y plus 2 equals to ln x minus 1 plus c. So now if you want to get rid of ln, so it'll become y plus 2 absolute values e to the power ln absolute value of x minus 1 plus c. And of course, you can make y the subject, whatever it is has been given to you. So this is the basic skill of solving differential equation by separation of variables. Now let's take another examples on the partial that involves partial fraction. So when you look at the question number 8 here, the question is, the first part is that express this as a partial fraction. Now, when it is a partial fraction, just as for this problem explicitly, I'm just clarifying that if it is, let's say, a linear 8x plus 3 over, now if you factor this out, you're going to get x minus 4 and x plus 3. So when you got the distinct factors in denominator and the degree of numerator is lesser than degree of denominator, then you can just simply do a over the first factor plus b over the second factor. So now here it's up to us that you want whichever you want to keep first. So I can just, after this, I can just solve it. Like I can cross multiply it here. I'm just doing the same thing out here as well. So if I cross multiply, I get 8x plus 3 equals to, if you multiply this here, x minus 4 get cancelled. So you get a times x plus 3 and plus b times x minus 4. Now after this, what you do is next is to, you can substitute once x equals to negative 3 both the sides, or and once you substitute x equals to 4 both the sides. So when I substitute x is negative 3 both the sides, what I get is the answer for b, which is 3. And when I substitute x as 4 both the sides, it'll become 3 times 4, sorry, 8 times 4 plus 3 equals to 8 times 7 equals to 0. Now this is a quick technique, and the other technique could have been that you set up two simultaneous equations and compare the terms. So a plus b times x, if I would have taken the right hand side simplification, and the constant term could have been 3a minus 4 times b. So if I would equate the real part, real coefficient of x is a plus b is 8 and 3a minus 4b is 3. So 3a minus 4b is 3. If you would have solved them, you would have got the answer for b as 3 and a as 5. Now our next step is to solve the differential equation that has been given here. So somewhere you have to use the like hence word. Like lots of time they don't use this for hence word, but that is hidden here. So let's see how do we solve this equation. Now to solve this here, what we got is dy by dx equals to 8x root y plus 3 root y over x square minus x minus 12. Now you can clearly see that if I take root y common, what we get is 8x plus 3 over x square minus x minus 12. Now you bring root y to the other side, so dy over root y equals to dx 8x plus 3 over x square minus x minus 12. Now obviously to solve the differential equation, you integrate both the sides. So this part can be integrated easily, but this is something for which you got to use this partial fraction that we just wrote. Now what we get is that here I can integrate this as y to the power half upon half equals to, this can be integrated as a is 5 over x minus 4 and plus b is let's say 3 over x plus 3. So this is, I'm just rewriting the expressions, and this integration is 5 ln x minus 4 plus 3 ln x plus 3. And so when you simplify this, it is 2y to the power half is 5 ln x minus 4 plus 3 ln x plus 3. And then you can just make y the subject, I can just clearly show the exact answer that we get for this problem here. Now, so this is the answer that we get. So you write down this as a single fraction by using the log properties. So this comes back in power, this goes back in power. And for writing the constant, instead of writing as c, you could take ln c in order to get rid of the, or write this as a single like factor. So I can, I have written ln a plus ln b plus ln c as ln a, b, and c. And of course, now they have given the initial condition. So they have given some x values and they have given some y, so you can find out the exact c value from there.